Hello, this is Dr. Jabitsky and welcome to my Environmental Science Screencast. Today we are going to talk about the scientific data analysis. Hello. And today we are going to discuss a little bit more how the science is done, and we will look at some very important elements, how we analyze scientific data. So you remember that data analysis is one of the crucial steps of the scientific method. Scientists are often working with very large amount of data, and to make their life easier in terms of data analysis, they're using graphs. So graphs are pretty much, in a nutshell, are pictures, and this type of pictures will be used in science to present data. And graphs are very beneficial because when we use graphs, it is easier for us to see the patterns or trends or connection between different things that we are investigating. There will be many graphs in this textbook, as you will see, and to be able to construct the graph correctly, to be able to read the graph correctly, this is considered to be a very essential skill that any college graduate needs to possess. And I wanted to mention that graphs are not only useful in science, they can be very useful in everyday life, because you might be reading a newspaper article that will show you the change of the stock market, for example, or you will be watching a TV and you will see some type of newscast or a show where statistical data of unemployment or job creation or coronavirus infection are shown. So it's kind of very important to be able to understand what a particular type of graph is telling us. So once again, data analysis and graphs are very important in general. So if you're gonna look at the definition of a graph here, it says that a graph is a diagram that shows relationship between different factors. So frequently, those factors are called variable, right? And so what exactly is a variable? A variable is a factor that fluctuates, that changes, right? So for example, if I'm going to take outdoor temperature at different time of the day, it's gonna be probably colder at night and warmer at noon, right? So what happens, the temperature throughout the course of the day will change. So the temperature is a variable which is present in our environment. So if we're going to analyze, for example, an unemployment rate in our society, and we're going to compare different months of 2020 or any other year, those numbers also going to be different. So an unemployment rate in this example is also a variable. So there are many variables in our environment, even the duration of the day is different. It's not, exactly the same, and that's why we have leap years, right, when we have one extra day. Okay, so the variables are usually presented using two different axes. And so one of them is called the x-axis and another one is called the y-axis. So let's talk about it. So the x-axis is usually the horizontal axis. Horizontal means it's parallel to the horizon, so you can remember it this way. And then we also have the second axis, which is called the y-axis, and the y-axis is usually the vertical axis, which is going to be perpendicular to the x-axis. So you can imagine that if you have some type of an assignment that calls you to put some variable to the x-axis and some variable to the y-axis, right, you will know what those terms are. So very well. So we know what the variables are, and we also know the difference between the x and the y-axis. So most of the time, the x-axis reflects so-called independent variable, when the y-axis will represent so-called dependent variables. All right, so let's talk about the difference between the dependent and independent variables. So first of all, the independent variable is a variable that you have total control over, right? So when you plan your experiment, you decide what kind of measurements you will be conducting and how, and this is what will determine your independent variable. So the dependent variable is something that you are not sure ahead of time how this variable will behave, and that's why you need to conduct this experiment and do the measurements to determine how this dependent variable will behave. So in our original example, when I'm getting outside and I'm taking outdoor temperature, I can decide that I'm gonna take the temperature every hour starting at 6 a.m. So I'm gonna take the temperature at 6 a.m., at 7 a.m., at 8 a.m., at 9 a.m., etc., until 6 p.m., for example, right? So the time is a variable. But I decide that I'm gonna conduct my measurement every hour at 6, 7, 8 a.m., etc. So this is my independent variable because I independently made my mind how I am gonna do my measurements. If I wanted to, I could make these measurements every 2 hours or every 3 hours, right? So the temperature will be the dependent variable. So depending at what time of the day I will conduct my measurements, I will get a different number. So I may have some idea that the temperature will go up, but I might not know exactly by how many degrees. That's why I am conducting this experiment, right? So in my experiments, once again, the time of the day is my independent variable. This is something that I have control. I plan to do measurements at certain times of the day. And my dependent variable, which will depend on the time of the day, would be the temperature of the air outside. So now if I would have to put my data on a graph where I would put my independent variable, and independent variable is going to be the time of the day, 6, 7, 8 a.m., etc. It will go to the horizontal axis, to the x-axis. And where I am going to put the temperature of the outdoor air, this is my dependent variable, and the dependent variable will be reflected on the vertical axis, which is my y-axis. All right, so let's take a look at the main types of graphs. So the first graph that we are going to review is so-called line graph. Okay, so there will be different examples of line graphs. So for example, this particular graph, which is in figure 1, shows trend over time, right? So this particular graph, figure 1, will show coal consumption by different countries over 50 years period. All right, so let's take a look at this graph. So we have our x-axis. X-axis is the vertical axis over here. And we have the consumption of coal over here. And what we have at the x-axis is the time, the years. And you can see the measurements are done every 5 years. So 1980, 1985, 1990, 1995, 2000, etc., etc. And it's look like there is also an estimate of consumption or projection, right? This is something that we can do when we use scientific modeling. This projection and estimate up to 2035. And pretty much we see here that the line graph sometimes can have more than one line. And in this example, we are looking at different countries. We are looking at the United States, we are looking at China, India, and all other countries. And if you would present these numbers in form of a table, it probably would be a little difficult to, grasp the idea. But it takes just a moment to see that here we have a very sharp increase in coal consumption by China, right? So United States in 2020 consumes certain amount of coal, and the projections are pretty much that this consumption of coal will stay the same, right? But obviously we also have to figure out when this chart was published, right? And so if it was published during President Obama's administration, when we were kind of moving towards alternative sources of energy, so that could be true, but I'm not really sure that the contemporary estimate is the same. But for our purpose, what is important here is just to understand what a line graph is. And actually, if we pay attention here and we will read the description of this graph in the textbook, it says that data for this graph were collected in 2012. And so probably if we would interpret this the same type of data in 2020, which is 8 years after 2012, probably there would be some changes, right? And what is shown here in this graph, this is 2012. So up to this dotted line, these are actual data. After this line, this is modeling, right? This is projection. So the second type of graph that we are going to look at is the bar graph. And so sometimes graphs are also called charts. So we can say a bar graph or bar chart. This type of charts are used when one variable is a category and the other variable is a number, right? So on the line chart, both variables were numbers, right? On a bar chart, only one variable is a number, but the second variable is a category. So this particular bar chart shows us a cost and benefit analysis of the provision of so-called the Clean Air Act. And so the Clean Air Act is a law of the United States of America that is directed to protect the quality of the air that surrounds us. And so obviously to implement this law, we have to spend, certain resources, but the benefits of implementing this law can be a lot greater. And so let's take a look at the bar chart. So remember, on the bar chart, one variable is a number. And so the number is the cost and benefit in billion of dollars over here. The two categories are the cost and the benefit. The cost and the benefit, right? And for each year, we have two bars here. The red bar is the cost, and the blue bar or purple bar would be the benefits. Right, so this is a typical bar chart. We have two categories that shows us billions of dollars. The costs and the benefits are the two categories. And since we are already looking at this graph, let's just mention what costs and benefits could be associated with the Clean Air Act. So there probably should be some cost associated with protecting the air, right? So if you have a factory and the factory has a chimney, and out of the chimney, the factory puts some pollutants to the air. And these pollutants can, circulate in the air, and some people who live in the vicinity of the factory can inhale, right? And maybe later they will get sick, or they will develop lung cancer, for example. I'm exaggerating, right? So obviously, it does cost something for the management of this factory to install some type of filters so those pollutants wouldn't go to the air, and it can be quite expensive. But if we think about human health, right? So what does it cost to treat the person who is sick? How the economy can be impacted if the person is out of the workforce, etc., etc. So the benefits of installing those traps to collect the air pollutants actually better. So if we are gonna improve the health in the community, that would be a lot more beneficial for the economy overall. So the benefits of the implementation of this law are a lot greater than the cost of implementation of the Clean Air Act. And it's not only just the human health, but also those pollutants can negatively affect the environment, even the buildings and the structures and the monuments, and they can affect, farmed animals and agricultural products. So there's a lot of things which are associated with the air pollution, right? And so the overall benefit, of course, outweighs the cost. And the third type of common graphs that we are going to experience very often are so-called pie graphs or pie charts that compare portion of a whole. And so obviously you're familiar with pies, and everybody probably has their own favorite pie. Some people like blueberry pie, and some people like apple pie, or whatever your favorite pie is. But in science, pies are not edible. Pies are actually charts or graphs, and they represent portion of a whole. So in this particular example, so we are looking at the proven oil reserves by countries, as shown in this figure. So let's take a look. So let's take a look if we can. So here we go. This is actually representation of oil resources by country. So if we consider the entire resources of oil on the planet to be 100%, what percentage of those oil reserves would be associated with a particular country? The main idea here is that oil reserves are very unequally distributed. So in the Middle East, such as Saudi Arabia, Iran and Iraq and Kuwait, we have a huge chunk of the oil, right? Then Venezuela is another country that has a lot of oil. If you look at the United States only has approximately 1% of the world oil reserves. So we can see here that the slice of the pie represents the percentage of the oil resources, right? So the greater is the slice of the pie, the greater would be the oil reserves of a particular country. So obviously we can say that Venezuela has, for example, more oil than Canada, right? And Canada has more oil than, let's say, the United States. So let's summarize what we know about graphs. So graphs can be of different types, and the three most common types of graphs are going to be the line graphs. That's going to be number one. So number two is going to be bar graphs. And number three, we will have pie graphs or pie charts. There are other types of graphs that can be also sometimes found in science, but these are the three most common ones. We're also familiar with the definition of the x and y axis, and we also know the difference between dependent and independent variables. So another thing that I wanted to point out that especially if you have several graphs in a lab report or in a chapter of a book, they should be numbered. So for example, this particular graph is figure 4, and the graph is supposed to have a title. So the title of this graph is pie chart, because it just, this particular chapter is just talking about the most common types of graphs, right? So it's a pie chart. So if this chapter would be about oil and some other types of conventional resources, probably the figure title would be pie chart of proven oil reserves by country, right? So because when you are looking at the title of the chart, you should already know what the chart is about. Very well. And so what I would like to do next with you, I would like to show you how you can easily make graphs using Microsoft Excel. And so in this particular example, I'm using Microsoft Excel of the Microsoft Office 365, the online version, which is available to all our students. So if you're going to use the desktop version of the software, it is very similar. So very frequently, the graph is necessary, for example, for a lab report, and the Microsoft programs such as Microsoft Excel would be the starting point to construct the graph, and then you can transfer this graph, if necessary, to the Word document if you are typing a lab report, or to the PowerPoint if you are making a slide presentation. So to begin, we need a set of numbers, right? So we need some type of dependent and independent variables with measurements, so we can start making graph. All right, so we're gonna start making a graph. But before we will start making a graph, I'm gonna tell you a story. Alright, so Dr. Gembitsky had a kitten, and so the kitten's name was Fedor Diamond. And Dr. Gembitsky was raising the kitten and decided that he is going to measure the mass of the kitten to follow the kitten's growth. And so almost every day, Dr. Gembitsky would put the kitten on the scales and measure the mass of the kitten in grams. And just to give you an idea of grams, so the mass of a pencil is approximately 5 grams. Alright, so we are back to the Excel spreadsheet, and we have our measurements, and we can put those measurements in the table. And there will be obviously two variables. One is gonna be time, and another one is gonna be mass of the kitten in grams. So which of these two variables is independent variable? So if you say time, you are correct, because Dr. Jambitsky decides when to make the measurements, right? So this is independent variable. But Dr. Jambitsky doesn't know what exactly the mass of the kitten would be on a particular day. It will depend on the age of the kitten, right? And how fast the kitten is developing and growing. So the mass of the kitten in grams is going to be our dependent variable. So in our table, we probably need maybe two columns. And one is going to be the time, or we can also say age of the kitten. And the second one is going to be the mass of the kitten in grams. And what we can do here, over here, we can go to insert, and we can insert the table. Usually, before we insert something somewhere in Excel spreadsheet, we have to indicate what exactly is the place where the table, for example, is going to be inserted. And this is done by highlighting a particular area. So what I'm going to do, I'm going to just highlight several cells where I would like my table to be. So for example, I can start over here. And I have two columns, and remember the two columns would be the age of the kitten and the mass of the kitten in grams. And let's see, I have 10 measurements, and so if I have 10 measurements, I need 11 rows here. And let's try to insert the table here. And Excel asking if I'm sure this is where I would like to place my table. I will have headers, yes, so I will say yes, and I will click OK. Now I can pick different designs. So I do like a blue color, and maybe this is not a bad design. But maybe I will go with this one, right? Okay, so here's my table, column 1 and column 2. So column 1, and I can also sort it if I would like to, and column 2. I'm gonna try to see if I can change the title over here. So what if I will go over here, and instead of column 1, I will say kitten age, kitten age, right? So kitten age in days, for example. So I will put days in parentheses, and it's look like this is a little bit too long, so doesn't fit my cell, but I can move it so I can see the entire title of this column, kitten age and days. And here we go. That's not bad. And for this column, I'm gonna say kitten mass. Or you can say weight, but in science we say mass, right? So kitten age, kitten mass, and kitten mass is going to be in gram. G stands for grams. It's important to say the age in days because it can be in years, for example, right? Or the mass can be in pounds or in kilograms. So in science, it's always important to state the units of measurements. Okay, so something like this. Okay, so let's see what do we have here. So I have a measurement when the kitten was 2 days old, and the mass of the kitten when the kitten was 2 days old was 105 grams. And let's see, my next measurement would be when the kitten was, for example, 3 days old. And when the kitten was 3 days old, the mass was 147 grams. Let's see, the next measurement, for example, was 4 days old, and 172 grams was the mass. So the next measurement, let's see, let me skip some. So I'm gonna skip the measurement for the 5th day, just so we have different measurements, right? And let's see, 6th day is 105 grams. Day 6, 105 grams. No, 205, I'm sorry, kitten is growing. All right, 205 on day 6. Let's see, on day 8 is gonna be 248 grams. 248 grams. 248 grams. So day 9 is 260 grams. 260 grams. And then I have day, let's see, day 10, 280 grams. Day 10 is 280 grams. And let's see, let's pick up another measurement here. So we're looking at day 10, right? Okay, let's see, for example, day 15. Day 15, we are looking at 340 grams on day 15, which is going to be a little bit over 2 weeks old, right? So what did I say? 340 grams, right? 340 grams. Okay, so this is my table. So once again, kitten age, which is time, this is my independent variable. Kitten mass is my dependent variable. Alright, so now I'm gonna make a line chart. And to do this, first of all, I have to highlight this area over here that will go to the graph. And then I will go at the top to the insert. And now instead of inserting the table, I have to insert some type of a chart. And for this type of a chart, which is XY line chart, I recommend to use scatter chart option here. All right, and I would like to have dots, and dots are called markers, and I want them to be connected with straight lines. So I'm going to select this option over here. Right, scatter with straight lines and markers, which compares pair of two values. I'm going to click on this, and immediately I have a beautiful graph here that I have to customize. So this is an automatically generated chart or graph, so I have to customize it. So from insert, I have to go over here to the chart, and that will give you more options what this chart is supposed to look like. And I can do several things here. So for example, I can give this chart a title or no title, right? So what was written there, so that was not really a good title. So let's and we also want to decide where the title is gonna be. For example, if we want the title to be at the top, we select a particular option at the top, in the center, above the chart, and we have options to have no title at all. So for example, let's say, remember we have to give it a number and the name, so it's going to be figure 1, and let's see, we call it Kitten Grows. Kitten Grows. That sounds like a good title, right? Okay, where it will go over here. All right, so I also, if I wanted to, I could move this title somewhere else. I could put it above the chart like this. And I think it looks slightly better when I place it above the chart. Okay, now I also have to name my axis, and so they're gonna be kitten age and kitten mass. So if I would like to see what's written in the table, I can move my chart over here, and axis titles. So primary horizontal axis title. Okay, and again, if I don't like what I see there, I can say none, or I can also type this, kitten age in days, right? So we are going back to the chart. We are going to go to axis title, and let's name it, and let's name this kitten age in days. Kitten age in days. Okay, here we go, kitten age in days. And we also would like to name this axis as well, and this is gonna be my primary vertical axis title. And let's give it a name as well. It's gonna be kitten mass in grams. Let's see what it's look like. All right, that looks pretty good. We can also rotate this if we have to. And we have an option to have a legend. We can place a legend over here if you want, or we can delete it. So I think in this particular case, because I have only one kitten, I only have fade word diamond, I don't need to have a legend. If I would have second kitten and I would show those dots and lines in 2 different colors, then I would need a legend. So this looks like a pretty good graph, and if I want to insert this into, for example, Word document, I can, or a PowerPoint slide, so I can just copy it. I do a right click and copy, or I can do Control C to copy it. And now I can open my Microsoft Word. Okay, and for example, I would like to start a brand new document here. So now I am in Microsoft Word, and here actually the paste isn't working the same way as in the desktop application, but I can still paste it, but instead of right click I have to do Control V. Okay, so I'm gonna say okay, and I will use my keyboard to paste my graph. So I can put it in the middle if I would like to, for example, by pushing over here, but I have to highlight it first, and I can position it in the center. I can change the size of this graph if I want to, and I can also type here my lab report. So I'm not going to type anything right now, but you got an idea. So this is pretty convenient way how quickly create a nice graph. What is important that your graph should have a number, a title, and the axes have to be labeled correctly, and also with the units of measurement. In this particular case, for the age, it's going to be days, and for the mass, it's going to be grams. No matter what kind of variables are on your graphs, you have to have units of measurements. All right, so now I would like to show you how to make a different type of a graph. We are in chapter 15 right now, and we are talking about atmosphere in this chapter. So the atmosphere is the air shell that surrounds the planet Earth, and the atmosphere is actually a mixture of gases. It's not just oxygen. And so we have this table here, 15.1, that shows us the composition of clean, dry air. So what does it mean? That the water vapor isn't present. And we already talked about the composition of the atmosphere before, and we mentioned that oxygen is only approximately 21% of the air composition, which is shown over here. Most of it is nitrogen. 78% of the air composition is nitrogen. Carbon dioxide is approximately 0.4% if we round it up. And carbon dioxide is a powerful greenhouse gas, and carbon dioxide traps heat in the atmosphere, and the more carbon dioxide we have, as you already know, the warmer is the climate. So these are our three major ingredients here. So the rest of the gases are pretty insignificant. We can say that argon is approximately 0.9%, right? And the rest of the gases would be quite insignificant compared to these four. And so obviously this is a composition of clean air with no air pollutants. So let's look at this information and use it to construct a graph. So we are back to our spreadsheet, and we can scroll a little bit so we can start a new graph somewhere over here. So let's take a look what we have. So we have different gases and their percentage. And so we are going to show nitrogen, we are going to show oxygen, carbon dioxide, right? And argon. So oxygen, carbon dioxide, nitrogen, argon, and everything else. So that's going to be 5 lines and the header. Okay, so let's do 1, 2, 3, 4, 5, and the header. I think this is what will be enough. We are gonna again go ahead and insert the table. Yes, I will have the header. And I want this one. So here we go. So here I will have column 1, and I will say that column 1 will have name of a gas, right? And column number 2 will be percentage. So percentage of the gas. All right, and we have nitrogen. we have also we have oxygen, we have carbon dioxide. Well, actually, let's do this. Carbon dioxide, argon, and others, because we have to have 100% at the end. So 78% is nitrogen, 21% is oxygen. Carbon dioxide, we said approximately 0.04%. Argon is approximately 0.9%. So now what do we have left? So what we have left is 0.06%. That's going to be everything else. So I'll be ready to make a chart. So to do this, again, I have to highlight this area, and I have to go up top here and insert the chart. All right, so I'm going here, and I would like to insert the pie chart. This shape, for example, right? Displays the contribution of each value to total. And so nitrogen is blue, oxygen is orange, carbon dioxide, I think maybe gray color. Argon is kind of yellowish, and others is a different shade of blue. Okay, so now I can change these colors if I want, but to edit my chart, I have to go to Chart Tools. All right, so I can have the title. So here we go. There is no title right now, but I can add the title above the chart. I can say composition of clean, dry air. Composition of clean, dry air. So I have other options here. These are my legends. So I can show them in different places. So I could, for example, put them next to the chart like this, and this can be easier for us to read. These are my legends. I can also go over here and I can add data labels, and there are different ways how to do it. For example, I can do it like this. That shows actually the percentage. It doesn't say the percent, right? And I can reposition it, for example, like this, but that doesn't look very well, right? I can put inside. It also seems to be crowded, so probably best fit. This is a better way. So what I'm doing here, I'm going back to my original table, and I am changing here the absolute number to percentage, and that would actually make my chart to look a little bit different until I completely finished this percentage change. Okay, now it is the same as before, but it actually indicates a percentage. Okay, so it's pretty nice. Once again, I can highlight this and do Control-C for copy, or right-click and copy. And I can go to my Microsoft Word document and paste it. Alright, so it will go over here, but I forgot that I have to give the number to my figure. I already have figure 1, so it has to be figure 2. I'm back to my chart, and to the Chart Tools, and I want to change the title. Edit the title, so I have to say figure 2, this is something that I missed. Okay, and I have to copy it again and move it to the Word. Here is my presumable lab report. I may do Control V, and here's my figure 2. So I have figure 1 and I have my figure 2. Okay, and so let's also make the third type of graph, which is a bar graph. And those names of the gases also could be categories, right? Because they're not numbers. So not only I can make a pie chart from this table, but I can probably also make another type of graph, which is called bar graph. So what I'm doing, I am again highlighting this area, and I'm going to insert now the bar graph. All right, and these are the options. So I probably want this type of a bar graph, or either this way, or maybe I want it to be in form of a column like this, right? So let's see what is gonna happen here. Yeah, this is one option. And we can also try instead of a column to use a bar graph like this in this direction, which is pretty much similar, right? It's about the same. It's about the same. So this way or the other way doesn't matter. And I decided to go with the original column graph over here. There are other types of charts over here we can check, but they seems to be a little bit more sophisticated. There is some type of a statistical histogram. Okay, and let's see what this look like. Yeah, this is probably not what we want. So I would say we go back to the column graph of this type. All right, obviously carbon dioxide is less than 1%, so we can barely see it over here, right? Again, what choices do we have here? Chart title. So let's say, okay, I think what we have to do, maybe we have to first erase the title. Okay, and now we can write a new title, and this is going to be our figure 3 composition of clean dry air. So it's pretty much the same, but it is a bar chart. All right, so let's see. This is kind of percentage. We have an option to name the axis, but primary horizontal axis already kind of clear. Vertical axis possibly should be percentage of gas. Okay, legend. Legend might be not necessary, but if I want, I can put the data table here, right? So for example, I can put those numbers like this, right, outside of the bars. So what does it look to you? I think that's pretty good, right? So the same thing, I'm gonna copy this and I'm gonna transfer this to my lab report. So I am in the Microsoft Word now, and I am going to do Control V to place my graph. It looked like I went over the page break. So what I could do, I could just move it to the next page, or I can add a little bit more room between them. Okay, and another way to kind of take care of it is to change the shape, or I would say not the shape but the size of the graphs, right? So we can make them bigger or smaller. We can even align them to be exactly the same size if you want. Right, so here I'm kind of running out of room. I can put each of them on a separate page if I would like. I make them bigger if I would like. So I have a lot of flexibility what I can do with those charts in my Microsoft Word, and I can also add text if it is a lab report. Alright, so I hope now you understand how you can create graphs and how you can read graphs in your environmental science class and in any other circumstances. So if you have questions, you know how to get in touch with me, and I will talk to you soon.